Hello again, algebra students. So today's lesson, we are going to be going through linear functions. So what you need to make sure that you do is get a lesson sheet from the substitute. It should be labeled topic linear functions, and it starts with having a set of graphs at the top and then a graph with points at the bottom. What you're going to do today is just like yesterday. You're going to go on to Schoology and you're going to watch lesson number 3. Then as you're going through the notes, you're going to engage with them, and then you are going to work on your homework number 3 on Pearson. So let's get started. You already have our essential question labeled. What are the linear functions and how are they useful? So we are going to take what we learned the last 2 days with functions and we are going to put them into a new lesson and discuss what the linear piece of it is. Today's date is the 12th, so you can label that to 12/20. All right, so we're going to do a little launch here. There are 4 different graphs. And it says to draw lines to group 1 and group 2 to sort them, and then describe each of the groups. So looking at these 4 different graphs, what are some things that are similar? Well, I noticed that the first graph and the last graph are curved, and then the second graph and the fourth graph are straight lines. So I am going to draw an arrow to group 1 for my second and my fourth, and I'm going to put the word straight. There's straight lines. And then from my first and my third, they are curved. So this is the type of stuff that we're going to be talking about today and tomorrow. When you see lines that are straight, they are considered linear functions. A linear function creates a straight line that has a constant rate of change. Ones that are curved are nonlinear. So anything that has a break in the line or isn't a straight line is going to be considered nonlinear. All right, our 2 words for the day: linear and rate of change. A linear function is one that has a constant rate of change, meaning that it is continuously going up or down by the same value, and it creates that straight line. The rate of change is the comparison between the 2 quantities that are changing. So we are going to be looking at both of these today. Again, as we go through this lesson, pause whenever that you feel you need to, and then just start it back up. All right, it says graph a set of ordered pairs to determine if they are linear. If so, find the rate of change. Use a different color to connect the points on the line. So at this point, I'd probably go and get, you have a pencil or pen, and I would go and get 2 other colors or borrow your neighbor's type thing. So let's start with A. I'm going to use purple. Right, purple? Yep. All right, so I have 1, 5. Now remember, when you're on a graph, your y positive goes up. Your y negative goes down. X negative goes to the left, and x positive is to the right. And when we graph a point, it is x and then y. So we start by going side to side, and then we go up and down. So when I start with 1, 5, x is 1, 5 is y. So 1 means, I always start at the origin. I'm going to go 1 to the right because it's positive, so 1. Then I go up 5. 1, 2, 3, 4, 5. And I plot my point. Then I have 2, 7. So I'm going to start in the middle again. 2 positive means I go to the right 2. 7 positive means I go up 7. And it goes right there. 3, 9. So again, start in the middle. 3, 9. And unfortunately, the graph I put does not have us go anymore, so we can't actually do these last 2. So let's connect these here. Does this look like it represents a linear function, meaning it made a straight line? If you said yes, then you're right. So we're going to say yes. Now to find the rate of change, the change in y, change in x. So let's look at these two numbers. My x's are 2, 3. So to go from 2 to 3, am I going up 1 or down 1? I went up 1. Then my y's, 7 to 9. What am I going up from? I'm going up 2. So change in y over x. So my y over my x. My y was changing by 2. My x was changing by 1. And what is 2 divided by 1? 2. So yes, your rate of change is 2. All right, let's try it again. I'm going to use pink this time. All right, 0, 0. That is just right in the middle. 1, 1. Go to the right 1, up 1. 2, 4. So go to the right 2, up 4. And then 3, 9, right 3, up 9. Well, look at this graph. Does this make a straight line? Nope. And because it does not make a straight line and it's curved, it's non-linear, so it's just a no. Determine if it's linear. No. All right, I'll use green this time. 1, negative 1. So 1, negative this time means I'm going to go down 1. Then 2, 2. 3, 5. 4, 8. Well, this looks like it makes a linear line. So let's see. 1 to 2 is going up 1. Let me just check again. 2 to 3, up 1. 3 to 4, up 1. So remember, it's y over x. So this is all the same of 1. Now, negative 1 to 2. So I'm at negative 1. To get here, I went up 1, 2, 3. 2 to 5. Again, up 3. 5 to 8. Up 3. Well, is that all the same? Yes. So I'm going up 3 over 1. So my rate of change is 3. So yes, it is linear, and my rate of change is 3. And we'll review that more too. That's what your whole next unit's on. All right. Now we're going to look at tables. Does the table represent a linear function? So we, again, are doing what we just did, where we are going to look at the input versus the output. So when I look here, I'm going to look at what the rate of change is. So 1 to 2, I am adding 1. 2 to 3, adding 1. 3 to 4, adding 1. 4 to 5, adding 1. Now 5 to 8, I'm adding 3. So right now, 3 divided by 1 gives me 3. 8 to 11, again, is adding 3. Still the same thing. 11 to 14, adding 3. The same thing. 14 to 17, adding 3. The same thing. So each time, we are going to go our y over our x, which is our output over our input. So our output every single time was the same number. It was 3. Every single time it's the same for the input, 1. Because they are the same, yes, it is a linear function. So let's try it for this next one. This difference is positive 3. Positive 3, positive 3, positive 3. So the difference between 0 to 3 is going up 3. 3 to 6, I add 3. 6 to 9, I add 3. 9 to 12, I add 3. So far my input's the same. But now let's look at our output, and I think you're going to notice something right away. 0 to 1, I add 1. 1 to 3, was 1 plus 1 3? No, I added 2. Are these the same? No. So we don't have to go any further. The fact that they are already different in their values right away means that it's not linear. It needs to be the same consistently.